Okay, so here are the notes and instructions for the Will It Topple problem. This will be a oral communication grade, an innovation grade, and I believe a professional ethics grade. All of that information is in the modules. So let me go ahead and read through this. It says the Leaning Tower of Pisa is a bell tower in Italy. It's famous for not being plumb to the ground. What plumb to the ground means is that it's not straight up and down. It goes at a lean. This problem was caused by inadequate foundation and soil that is too soft on one side of the building. This kind of connects back to our stabilized dirt problem, making it unable to support the weight of the building. Below is a picture of the tower. Okay. Then it says in 2001, work was done to straighten the tower and prevent it from toppling. After the work was completed, surveyors have found that the tower still leans, okay, at 3.96 degrees. So this is the current angle. Okay, that is as of today, that is the current angle, and the angle they're talking about is this one right here at the top. That's the angle of lean. And they've measured that that lean continues to slowly increase. So this angle is slowly getting bigger. Okay, what's important about that is if this angle is getting bigger, that means this distance right here is also getting bigger. To determine the rate that the tower lean is increasing, they hang a plumb line. What that means is they put somebody at the top of the building. A plumb line is basically just a string with a weight at the bottom so that it hangs straight down 90 degrees to the ground. So this line right here represents that string. It's called a plumb line that they put straight down. And then this is the horizontal distance, okay? They found that that distance is increasing an average of 1 centimeter per year. Surveyors say that the tower is safe from toppling until that distance increases to 5 meters. So this is a future amount. Okay, so keep in mind that this information and this information are at completely different times. So we can't use them together, okay? Those are two separate pieces of information. This is current day and this is someday in the future, okay? In what year would you expect the tower to topple if no work is done to restabilize the tower, and what would the angle of lean be for the building? Okay, so this question, okay, this is question number 1, okay. Actually, I'm gonna split this up. This is question number 1, this is question number 2. So to figure out what year, we know when it's gonna fall, but do we know what it started at? Well, we know the degree, but we don't know the distance, okay? So in order to figure out how long it's gonna take to get from here to here, we need to know this initial distance. We want to know the current horizontal distance, okay? So to answer question number 1, we're really gonna need 2 different triangles drawn. Okay, in the picture, it said that this was 44.62 meters. Remember, our angle for current is 3.96 degrees. And we do not know the horizontal distance for our current year. Remember, we can't put the 5 here because the 5 is sometime in the future. Now, at some point in the future, the building is still going to be 44.62 meters. The building is not going to shrink or get bigger. It's not a living object, okay? But we know at some point this distance will reach 5 meters, but the angle will be different. So that gives us 2 different types of triangle problems that we have to solve, okay? Remember, for question number 1, you need to find x. Okay. So, in order to find x, we need to label our parts of the triangle. Look at the 90-degree angle, go across, and that will always give you your hypotenuse. Okay. This is our theta. And if we start at our theta and go across, that's going to be our opposite. Okay, which means the adjacent is blank. So we're not going to use it. All right, so I'm not going to complete this problem for you all the way, but just let me give you a hint on how to finish this. So remember, you're going to look for the formula that has hypotenuse and opposite. Okay, I will tell you that if you use the correct formula and plug into this, x will be on top. Okay, so that was the very first lesson we did. That was the light pole problem. When x is on top, how do you solve it? Okay, so finish solving for that, and you will get your value for x. Then you're going to go back to the information that says that is increasing an average of 1 centimeter per year. Now keep in mind, our units here are meters, and this is in centimeters. That's not going to work. They have to match if we're going to make a mathematical calculation. So just keep in mind that 1 centimeter is equal to 0.01 meters per year. So once you know what this distance is, you're going to find the difference between them. So you're going to take the 5 meters and subtract whatever the current thing is. Okay. So that will be the change in distance. Okay, so if we want to know how many meters or how many years this is going to take, okay, then we are going to have to divide by that number. Okay. Okay, then, so we found how far it changed, and then we divided by the amount of centimeters that it's changing per year. Okay, and this will give us the number of years that it's going to take. All right, now keep in mind that it did ask in what year. So the number of years is not the same thing as saying in what year. Once you figure out how many years it's going to take, you'll need to add that to the current year, which is 2019.